So thank you very much. I am appreciate to present the implication of the performance of Internet of Things with the new technology which are going to come in Thailand. And actually, this is a great time period with all technologies come into the appropriate point which can introduce the new technology called IoT. The enabling technology which can initiate the IoT technology for such example, sensor technologies, communication technology, and machine learning algorithms, and also the hardware accelerations. And everything's become into ones with the good time to introduce the IoT technologies. So if you look at the advisory companies, the top 5, like a Gartner, they predict that the price of the components will be dropped from 2010 to 2005 from 15 to 45%. For example, the module of radios and the sensor temperatures is less than 30 baht. Okay, that was the good chance that the investor can produce the sensor node, and then we will get the massive of the information and can do the analytics and present surprising application to the customer. And this was the survey from the Europe that if we see from the chart that we see that the most invest for the investor was the embedded software. That means the existing hardware is enough for the IoT application. The hardware technology right now is enough for the IoT application. Some of the other is about software analytics and cloud computing is still invest on IoT technologies. This was all the basics configuration concept for IoT. It's composed of the sensor node. Yeah. Sensor node is combined of the sensor and actuator. And this was the local communications and the hub or backhauls. And the backhaul links along the hub and the cloud storage. Okay? In some cases, if the application is intensive, compute-intensive application, we all need the analytic engine for the local cloud. And also, in the cloud computing, we also need the accelerators. And the application on mobile can display in, can satisfy and appreciate for the user. This is overall the concept. So the point is that how IoT become deployed in Thailand. We can see that just the communications and analytics issue. So if we talk about the hardware accelerator, because finally there are a lot of information will be computed in the cloud storage. That means for sure that we need the hardware to accelerate the applications. If we look at the ICM 2016 conference, you can see that there are a lot of algorithms that need computation time, very high computation times. So that means we need very heavy computation to accelerate. One of the best is FPGA, which we can see for the example, the Google Superchart that how can the Google provide a voice search and street view and map navigations, because they use the TPUs to accelerate. And then the size of the GPU is like the same size of hard disk drive and plug in the data center. This was the key point that how IoT can be succeeded. Yeah. So another example, the difference among the accelerator from GPU to FPGA, because the GPU is more easier to program. And this was example of the NVIDIA's configuration of the CUDA unit, which can serve, for example, GeForce model, it can serve the transformation for computer graphics. And Coral is the design for the arrangement of the CUDA can serve the renderings of the surface. And the general computations model is for Tesla, is for general purpose mathematics. So this is also the example in case that the local cloud is deployed in the office, and then we still need the accelerator. This example was Captiva. This module is support the local oscillator. They have the least processor with multi-core. They have FPGA module inside, and they can provide OpenCL, MPI, and OpenMP for the developer. So why the FPGA accelerator is important for IoT technology? Because it can serve the nanosecond application. So it's what can do the very massive parallels computation. So, but anyhow, when compared GPU with FPGA, that FPGA we have to do the low-level hardware description language. It's really difficult when compared with the GPU with high-level language. Okay. So another key factor of the successful deployment IoT in Thailand was a communication radio access network. So up to now, there are two possibilities to be used in Thailand for IoT's application. One is LoRa radio network, and the second one is narrowband IoT. Okay, but both of these we call the low power wireless area networks. So they can serve the coverage. I mean, the coverage should be about 10 kilometers in radius, or 50 kilometers at least, and also it can take the many number of sensor nodes and graduate and send those data into the data center to be computed. Okay, and they have to take care about the battery lifetime. That if they use the very complex radio protocols, it will consume the sensor node, and then the sensor node cannot survive for the long periods. But usually for the concept of IoT, the sensor node at least should be survived 10 years. Okay, so that means the protocol to be used for IoT should be easy, and then can can insist the interference. Okay, so the first one, Aurora. Okay, actually the Aurora is what invented by a French scientist, and then in US company produced the chipset. Basically, LoRa is FSK, frequency shift keying modulation, but they modify some encode technique. It's called space spectrum modulation. So that means they use some series of frequency to send the informations, digital informations, from the sensor node to the gateway. Okay, the component of the LoRa, they have a sensor node and gateway, and the software management we call LoRaWAN. Okay, so with the technology called space spectrum modulation, because the signal data is sent with different frequency. So that means if they get interfere in one frequency, and the others can be survive and to send those data to the gateway. Okay, so okay, this was what is different between the LoRa network and like a mesh network for cellular. The LoRa network is configuration is like a star network. So that means the LoRa have no handoff. The handoff is mean when the sensor node is moved, okay, and then they have no traffic sending along the gateway, because the sensor node always stream up into the gateway and into the we call server network. The server network will be filtering redundant package, and mean the coverage of the LoRaWAN will be overlap among the area. That means when the sensor node is moved along the area, and the server network will be filtering and choose the one with a high field strength. Okay, and the good point is they no need to relay the package of the data from one gateway to the other. This is the good point for LoRa applications. So, but actually in Thailand, it seems to be that it's possible to use the frequency in length 868 megahertz. So actually, LoRa is a physical layer of OSI to serve the IoT technologies. Okay, the second chance that can be deployed in Thailand to serve the IoT application is narrowband IoT. Actually, narrowband IoT is use the same mechanism of the GSM, 2G, 3Gs, and 4G. But the point is, they just take one carrier with the 200 kilohertz to be used for IoT especially, okay? And then they maintain this frequency carrier. Even though the operator already moved the base station to serve only LTE, they can leave those carrier to serve the IoT because the modulation scheme for narrowband IoT is exactly the same as the 4G. So that means they can use the multiplexer to cross along the same carrier with different modulations. So this also, I mean, the first deployed radio network is a LoRaWAN, but the second choice is narrowband IoT, let's say. So that, thank you.
Please. Thank you so much, sir, for that information. Okay, at this point, we're going to have a short break, but we would like to request everyone to just sit still here. There will be like students serving us all, giving you coffees and some snacks. Okay? But if you need to go to the toilet, of course you can, but please one at a time. Okay, you can go to the toilet and then come back.
Sorry for that. Is there any questions and questions from Dr. Somrak? Any questions from the audience for Dr. Somrak?
Questions or clarifications?
Okay, there is no question. Thank you.
Very well explained, sir.
So forgive me for my English because I'm so nervous. Usually I'm always work in the lab. We have called Boundian Lab. We did the radio technology. We did the hardware design for the communication devices in CAT. And I have less chance to speak like in front of a lot of people like this, so I'm so nervous. Sorry for that.
Give him a round, please. Thank you so much, sir, for that information. Okay, at this point. Okay, sir. Thank you so much. Have a short break. A round of applause.